An electromagnetic pulse (EMP) refers to a short burst of electromagnetic radiation that can disrupt or damage electronic devices and electrical systems. It is typically caused by a high-intensity burst of electromagnetic energy, often originating from a nuclear explosion, although non-nuclear EMPs can also be generated using specialized equipment. EMP can be classified into three categories based on their source: nuclear EMP, NEM. This type of EMP is generated by the detonation of a nuclear weapon in the atmosphere, releasing intense electromagnetic radiation. The explosion produces three main components: the initial gamma rays, the high-energy neutrons, and the resulting electromagnetic radiation. The electromagnetic radiation, traveling at the speed of light, induces powerful electric currents in conductive materials and electronic systems, damaging or destroying their components. Non-nuclear EMP, NNEMP refers to EMPs created without the use of nuclear explosives. These EMPs can be generated by high-power microwave devices, such as specialized EMP weapons or devices known as EMP simulators. NNEMP weapons typically emit a focused electromagnetic beam, similar to a directed energy weapon, which can disrupt or disable electronic systems. Geomagnetic EMP, GEMPs are naturally occurring electromagnetic pulses caused by solar flares or other space weather events. When a massive solar flare erupts on the sun's surface, it releases a burst of radiation, including a coronal mass ejection, CME. If a CME reaches the Earth, it can induce strong electric currents in power lines, communication cables, and other conductive infrastructure, potentially causing widespread disruptions to electrical grids and electronic devices. The effects of an EMP can vary depending on the strength of the pulse, the distance from the source, and the resilience of the affected systems. In the case of a severe EMP event, such as a high-altitude nuclear detonation, it can potentially disrupt or damage power grids, communication networks, transportation systems, and electronic devices over a wide area, leading to widespread societal disruptions. Protecting critical infrastructure and developing resilient electronic systems are important considerations to mitigate the potential impact of EMP events.